We're going to pick up from yesterday on 3.2, and today's lesson involves, again, solving two-step equations by combining like terms, but today we're going to use good old friend distributive property. So let's take a look at our first problem right here. We have 3, and you should recognize by now x minus 2 equals 12. We have to use the distributive property. So when we do that, we get 3 times x is 3x, and 3 times minus 2 is minus 6 equals 12. Now, if we take a look at what we're going to do right here with 3x minus 6 equals 12, what's the first thing we're going to do? From yesterday's lesson, we're going to get rid of the constant. That's our first step. We're reverse PEMDAS. We're getting rid of addition and subtraction first. So since there's subtraction, we're going to add 6. And if we add 6, we're going to wind up with 3x equals 18. So our next step in two-step equations is to get rid of the coefficient. That's the number, of course, before the variable. So we're going to divide both sides by 3. Since we're multiplying by 3, we're going to divide by 3. And if we divide by 3, we're going to get x equals 6. I'm just going to take you through one more example of the distributive property, then combining like terms. So this problem is 7 times 3 minus x equals negative 21. Again, distribute 7 times 3, get 21. 7 times minus x equals minus 7x. Once we do that now, don't get confused by the order. This number here is going to be, we're going to treat this like a negative 7x and a positive 21. So now, even though they aren't 7x minus 7x plus 21, we're going to treat them independently. So let's take a look at the 21. How do we get rid of the plus 21? Well, since we're adding 21, we're going to subtract 21. We're going to subtract 21 over here as well. So we're going to be left with negative 7x, and then it's minus 21 equals minus 42. Now we're left with the coefficient of negative 7. So negative 7 times x is what we're doing. We want to do the opposite, so we're going to divide by negative 7. And that's going to equal a positive 6. We've got more examples coming right at you. Again, one more step. We did this in yesterday's do now a little bit, what we're going to do today. So if you look at this example, we have, if I just got rid of this 5x for now, just pretend that's not there, what would we do? Well, we'd multiply negative 2 times x and get negative 2x, and negative 2 times negative 1 and get positive 2. But the problem is, yes, we do actually have a 5x there. So we can't forget about that, but what we do is just bring that down. So now we're left with 5x minus 2x plus 2. So what we've been doing in the previous examples and earlier in chapter 2 was to combine like terms. And in this particular example, 5x and minus 2x are there. Integer rules apply, which means 5 minus 2 is 3. So it's going to be 3x plus 2. Now guess what? We're right back to a normal two-step equation. We get rid of the constant first. So we're going to add 2 already, so we're going to subtract 2 to get rid of the 2. And if we do that, 3x equals 6. Now we've got a coefficient of 3, so we're going to divide by 3, and yes, good old x equals 2.